Parametric curves, part 4. Number 1, sketch the curve given by the equations x equal 1 plus t, y equal 4 minus t squared. This is the parametric equation of this function. Write on your sketch the coordinates. We will have to find the coordinates of any points where the curve crosses the coordinate axis, means the x-intercept and y-intercept, and the coordinates of the stationary point, if any, which is maximum or minimum. Show that the equation of the normal to the curve at a point of parameter t is x minus ty equal 2t cubed minus 7t plus 1. It's given. We have to prove that there is a normal to the curve at a point of parameter t. This is the equation of the normal. Let's see. Let's start. First, as usual, we should find the domain. What is the domain of this function? 1 plus t is a polynomial. 4 minus t squared is a polynomial. So the domain is all set R, from minus infinity to plus infinity. Second, directly we go for the limits at the endpoints, or at the interval, endpoints of the interval. Limit of x of t as t approaches negative infinity is t is 1 plus x is 1 plus t, 1 minus infinity is minus infinity, and limit of x of t of y of t, let's say first, of y of t also as t approaches negative infinity, and here it's t, right? T approaches negative infinity is 4 minus t squared. T squared is minus infinity squared, which is positive infinity, times minus, it's also minus infinity. What's that mean? This means the curve starts, right, emanates from the which corner? From minus infinity abscissa, minus infinity ordinate, north, south, right? So it's from the south, or from the east-south or southeast corner. Southeast corner, right? Southwest corner. Sorry. This is the southwest corner, right? From the southwest corner. From minus infinity abscissa, minus infinity ordinate. And the limit of x of t as t approaches positive infinity is equal to positive infinity, and limit of y of t as t approaches positive infinity, it's equal to negative infinity, and that is from positive infinity of abscissa, negative infinity of ordinate. So this is from south, it terminates at southeast corner, right? Now, okay, for sure now we have to find the derivative, the first derivative, right? We should find the first derivative. Okay, again, this is the function. Okay, x dot is equal to 1, right? X 2 dots equal to 0. Let's prepare it for directly to find also the second derivative. Y dot is equal to minus 2t. Y 2 dots is equal to minus 2. This means the first derivative is equal to y dot over x dot, which is minus 2t divided by 1, that is negative 2t. Now, the sign of the derivative depends on the sign of t. Y prime will be negative and the curve is decreasing for t greater than 0. Y prime is positive for t less than 0. If t less than 0 times minus, it will be positive, right? This is important. Let's see what happens at t equals 0. Let's see what happens at t equals 0. Here we have a special point for t equals 0. For t equals 0, what happens to the derivative? Derivative is minus 2t minus 2 times 0, then it is 0. When we have derivative 0, this means, what do we have? When derivative 0, first we have horizontal tangent. At which point we have horizontal tangent? This means we have to substitute t equals 0 in x and y. X equal 1 plus t, so x equal 1. Y equal 4 minus t square, and t is 0, so y equal 4. So at 1, 0, the derivative is 0. So we have horizontal tangent at this, and this we consider it as what? As stationary point. He wants me to find the stationary points, right? This is a stationary point. What else? We found the second, the x2 dots, y2 dots, which are the derivatives of x and y in terms of parameter t. Let's find y double prime now. Y double prime is equal to y2 dots x dot minus y dot x 2 dots over x dot to the power 3. Then it will be equal negative 2 times 1 negative 2t times 0, right, over 1 to the power 3, and that is equal to negative 2. Negative 2, it's a constant number, negative constant number, so it's strictly negative. Then directly we can say the curve is concave downwards for any value of t in the domain, because we don't have any t here. So for any value, it doesn't affect the second derivative. Now let's find the abscissa, x-intercept and y-intercept, and that's what he asked me also to do in the question, right? Again, this is the function. let's find x-intercept or y-intercept first. If x equals 0, this is the y-intercept, right? If x equals 0, this implies 1 plus t equals 0, and that means t is equal to minus 1. For t is minus 1, it gives me y equal 4 minus 1 squared, so it's 4 minus 1, and y will be equal to 3. So at t is minus 1, we have a point of abscissa 0 and ordinate 3, right? This is the y-intercept. Now let's find for y equals 0. This means 4 minus t squared equals 0. This implies that t squared equals 4, and that gives me either t equal 2 or t equal minus 2, right? For t equal 2, what is x? For t equal 2, for t equal 2, this implies x, which is 1 plus t, it's 1 plus 2 is 3. So we have here a point, 3 abscissa and 0 ordinate. This is x-intercept. For t equal 2, we said. For t equal minus 2, this implies x, which is 1 plus t, it's 1 minus 2 equal minus 1. Another x-intercept is minus 1 abscissa 0 ordinate. Let's make sure that we know these points, because they are very important to the curve, right? What else we found? This is the y-intercept, 2 x-intercepts, and we found also a point, stationary point here, right? These are the most important points on the curve. Now we can draw the curve, and I think so I will not finish it before the time, so we will do next video for finish sketching and the other parts. Okay, let me continue until the video stops. Right, let's draw the curve, right? The y-intercept